All right, doing this problem called number of closed islands. I did a problem a while back and I saw I was just struggling to get to the answer. I just want to try it again today and see if I've improved at all or if I take the same amount of time. So let's have a read of the problem. Given a 2D grid contains of zeros and ones, so zeros is a land and ones is water. An island is a maximum four directionally connected group of zeros and a closed island is a island totally surrounded by ones. Okay. Return the number of closed islands. So closed islands are essentially the islands which are inside, right, which are not on the edges. And if they are on the inside, then definitely they are the uh, ones that we have to return. So in this example, so zeros are land. Lands is what we are interested in. Ones are water. Water is what we don't not interested in. So we look at all these zeros. This is all connected zeros, and this none of these zeros are on the edge, right? Some zeros that are on the edge, the ones that are on the edge are not fully surrounded by one, so you can't really call them inner or the closed islands. That is one. This is again. So these are the two closed. So if you look at the number of islands in this whatever you want to call this, this is one. Zero side. This is one, and this is one. This is one. There are four, out of which two are inner islands and two are edge islands, and that's why the answer is two. In this case, there are three different islands, but two of them are edges and only one is the inner island, and that is it. So how do we want to solve it? So basically, we find out the number of islands, or we find out the number of edge islands, then we can get the total number of inner islands. So what I mean is, you want to find out closed islands, and closed islands are essentially equals to total islands minus edge islands, right? Now, how do you find out total islands? First of all, so the way to find out total islands is so the islands is groups of land connected together, right? So go through all, go through the entire grid, and as soon as you find a zero, that means that's a land. So from that zero, do a DFS. That's the bit you have to check on, right? So from that, essentially, from that land, what are all the other land cells that I can reach? And all of them are all connected. So give that connected component some number, right? So that is one island. And then do the same for another. And now, so essentially you maintain like a island number for every. So for every cell, maintain island number or island ID, whatever, right? So as soon as you find the first land, so if this is a land, you will go in all the directions, whichever it is connected to, right? And make all of them as land. So this entire thing will become a one patch of land. All of them will get the same island number. And then there might be another one which is not connected to these. So if you first of all if you reach to any of these, then obviously you will find, hey, I already have an island number, so I don't have to do anything. And then I find another, as whenever I find a land which does not have an island number, I do a DFS from it. And whatever I find in the path, right, I'll give them, call it another island. At an any point, if I find a node at the edge, right? Any node at the edge, if that node at the edge is a land, then the island corresponding to it is an edge island, right? So you can maintain uh, a set of island numbers, right? So set of island numbers. So for every island ID, or you can maintain a set of island IDs that are actually edge IDs, right? And that would be just, hey, I'm a land and I am on the edge. Then, hey, what is your island ID? And whatever is the island ID, uh, that island ID should be added into this edge island set, right? And if all of them are connected, they will have the same island ID, and so we won't be doing replicated stuff. So that's the basic gist of it. Just do a DFS from all the land nodes which have not yet assigned an island number, right? Let's come to the code and see if it makes any sense. So the one thing that we're doing is for every grid, we are using a linear space and assigning um, island number, right? So we're assigning it an island number. So island number equals to, so new integer array of size grid dot, sorry for that, grid dot length and grid 0 dot length. Now I go and I also want to maintain a set of pager, and this is, I want to call it edge islands. And I also want to call maybe another thing, which is what was my last island, right? Last island number. So I want to maintain a count of islands as well, right? Just count of islands, right? So uh, just call it island count, yeah. And total island count is 0, right? And at the end, what I want to do is I just want to return total island count minus edge islands dot size, right? That's the gist. Now, how do I get the island count and the edge island set? So for each grid, I equals to 0, I is less than dot length, I plus plus, and j equals to 0, j is less than grid dot length, j plus plus. So for every node, you want to do a DFS, right? So I just call DFS, but yeah, just do D. Okay, so I call DFS. I pass in I pass in j, I pass in everything. So I pass in island number, I pass in edge islands, pass in island count. Okay, the island. So some of the things what I want to suggest is like these two. Let's make it public, or like global rather. So you don't have to pass. Okay. So these two I don't pass. So ij and island number is something that you need to pass. But what something is wrong. Set, okay, this is not real. Set islands, and you can, yeah, initialize again within the function. So you could do edge islands equals to new uh, sorry, new hash set, right? And okay, island count is 0. You can assign it again. All this is fine. And now you want to do DFS, so you do DFS int I int j. You would need the grid as well, right? Okay, so grid and int sorry about that, integer array again, a number. Now, what am I doing in this DFS? So first thing obviously is maybe I handle that here itself, which is, hey, if you are not water, then don't call DFS. So if you're not land, so if grade of ij, if you are a land, so if you are a land means you are 0 and you have not been assigned an island number. So and island number of ij is still 0. That means only then you probably would want to call DFS. Otherwise, there is no point in calling DFS. And actually, if that is the case, then this is where I would also want to do few things. What are the few things that you want to do? Tell me. So I would want to increment the island count here. So this will be an island count. And I'm gonna call DFS. Yes. And you're gonna do so now so basically when you're calling DFS, you know that the island number is 0. So you do, hey, your island number, you know what? Your island number is equals to island count. Okay. And there is other things as well, which is, hey, if I is less than 0 or j is less than 0, or I don't know if it's gonna happen, but if I is greater than equals to grid dot length or j is greater than equals to grid dot length, you know what? Just return. It's not a valid thing. So that's fine. And otherwise, if you are a valid node, whatever is the island number currently, I'm going to assign you that. Fair enough. And I want you to go to all your neighbors. So neighbors is all, there are 4 different directions. So I can call it moves equals to new. So you can either go to 0 minus, you can do 0 minus 1, random, right? So minus 1, 0, you can do a, you can do 0, 1, and you can do 1, 0. Okay, and since I am handling this here, I probably will also wanna then handle one more case, which is, okay, let's think about it. So these are all the different all the 4. Is it a problem? Like, yeah, this is extra, right? Yeah, okay. So I define new int like this. Now for each move in moves, so for each move in moves, I just want to do a DFS of I plus move of I, and then j plus move of, sorry, what? Yeah, I plus move of 0 and j plus move of 1, and grid and island number. All this is good, but hold on. What are you missing? There are a bunch of things that you're missing. One is, hey, you already have an island number. So which is this, or island number of ij is not equal to 0, right? If you already have an island number, that means you've already been visited. That's another way of also checking. Hey, yeah, I'm already been visited. Fine. Then this. Otherwise, you assign the island number and go to its children. There is one more thing I want to add, which is here. If I equals to 0 or j is equals to 0 or I is equals to grid dot length minus 1 or j equals to grid 0 dot length minus 1. That means, hey, whatever island this is, this specific island, edge islands, this is an edge island, man, right? So this specific island is an edge island, right? So you go through each and every land, right? And if that land is not already assigned an island number, then you do then you increment your island number and you do a DFS. And in that DFS, at any point, if you find a land node at the edge, then you call that island as the edge island. All right, let's run code and see if it works. And you got a wrong answer. Okay, still not great then. Um, how do we solve it? The way to fix it, obviously, like always, is to print the island number array. So equals to 0, is less than and I plus j equals to 0, j is less than j plus plus. So you print the island number of ij plus you give some space, oops, and after every row you give some leeway like that. Okay, run. Let's see what the problem is. So the problem is that you assigned a 1 to everything. First of all, you shouldn't have assigned 1 to everything because okay, so you missed one bit. If this is if this is a water, let's handle that also here, which is or this or you know what, if grid of ij is actually water, then I don't care. Okay, let's run. Okay, now let's see if this worked. So this was my input and I assigned this nice thing as 1, which was all fine, but these zeros did not get assigned anything. Why? What was the problem in these guys? What was the problem with these guys again? So I equals to 0, I less than island. No, so yeah, okay. Maybe it's just a stupid mistake. And run again. Yeah, now it works. So now we can see these are the island numbers assigned. I assigned this as this is one island, this is second island, this is third island, this is fourth island, and island number 1, island number 4 are edge islands, right? And then this is another case. Let's look at this example. In this example, again, you have 3 islands, and the 2 of them are water islands. Sorry, edge islands. Let's look at case 3. What is case 3? Case 3 is even a bigger one. But you see here, you have only 2 islands, and both of them actually are like edge, like inner island. So all good. Now I think we can remove this print. and submit. And finally, it works this time. All right.